All right, so like I said, these questions are meant to be harder. So you would never have a question on a Regents exam or something that we're doing that would specifically ask you to find something like this. All right, but these can become very much. They're all the same question after you do like three of them if you get good at them. So I tried to come up with some things here that might make you think a little bit more. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 12, 7, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 10, 1, 2, 3. All right, so we're H, Y, E, R. Okay, so there is my square. Now it wants me to do information about the diagonals. So there's one diagonal, and there's the other diagonal. I'm going to do them in different colors because it's going to make it a little uh, difficult to do in terms of things are going to cross that normally don't cross. So I've got YR, and then I've got EH, I believe it is. Yeah, EH. So I'm still going to do the same thing. I'm going to find the slope. I'm going to find the distance. All right, then we'll talk about if there's anything else I need to find in a second because I'm doing this for the first time and thinking about it as I go. All right, so now the question I would ask myself first is what needs to be true with the diagonals of a square? All right, so if I kind of work my way down through, they need to be equal. All right, so they need to be equal. That's going to come from their distance. They need to be perpendicular. That's going to come from the slopes. All right. And that's probably enough. But if I'm thinking about this, this is a rhombus. This is a equal distance is a rectangle or an isosceles trapezoid. And that would be enough. But if I'm kind of thinking about this, they really need to bisect each other, which is going to come from the midpoint. All right, more than likely, I haven't done any midpoint. I'm going to throw this in here just to be safe. That way, if I get all three of those are the three things a square needs to have true about it. So let's go to my red diagonal here. 1, 2, 3, 4, 5, 6, and 2. Both positive. And then 1, 2, 3, 4, 5, 6, but down 6 and right 2. All right, so my blue slope is down 6, right 2. My red slope is up 6, right, up 2, right 6. All right, so perfect because those are perpendicular. So there's one thing taken care of. And this is going to be negative 6 squared plus 2 squared equals c squared. That's 40, which means that that diagonal is square root of 40. This one's 2 squared plus 6 squared, which means that that one's also 40, which is good because they're both going to be square root of 40. All right, so what I figured out right here is that these are actually equal. All right, but the other thing that I probably should have happen here is I probably should make sure they have the same midpoint because they're supposed to bisect each other. Now, in reality, this is not, you wouldn't need to include this in your proof, but it's not really a terrible idea to do it. So the blue midpoint would be 1, 2, 3, 1. There's the blue midpoint. The red midpoint. 1, 2, 3, 1 is the same point, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So they both have the same midpoint. So 9, 6, 9, 6. That means they bisect each other. Okay? If they have the same midpoint, they both go through it. That means they must bisect each other. So I'm going to say right here, what the heck is it? It's HYER. HYER. So HYER is a square because it has congruent and perpendicular diagonals that bisect each. So again, that's a much more complicated proof. It's actually probably a little bit of less math than doing it the way we normally would do it. But it's just a different way to look at things.